So in this section, we'll investigate another interesting probability paradox called Hot Hand Fallacy. This term has come from gambling. And the idea is that, is it possible to have a very long streak of wins or losses in a game of chance, which is absolutely random in nature? There is no trickery or cheating involved. It's absolutely fair game. In such a scenario, is it possible to have a very freakish run of wins or loses? So we will investigate this phenomena. To start with, I've imported some libraries from Python, and we'll start with a variable called numPlay, which will decide the number of simulations that we are going to have. To start with, let's say 10 simulations. And with each simulation or game or toss of a flip of coin, we will record our wins and losses. So we have a counter called win counter, which will keep track of all the wins, and we initialize it to 0. And then we have a loss counter, which is also going to keep track of all the losses. Now, since these counters will get reset when the streak is over. For example, if there's a winning streak, and immediately after winning streak, if a loss happens, the win counter will be reset to 0, and this information will be lost. But I want to keep a track of all the streaks, both winning and losing, that have happened in the past. So to do that, I will initialize a list. I'll call it win streak list. It's just a Python list to save all the winning streaks, and I'll also initialize another list called lose streak, and this is also initialized to 0 value as of now. So now we'll initiate this game, and we will initialize a for loop which will simulate the number of plays that we want to have. In this case, we have initialized it to 10, and now we will simulate a random toss of coin, and its result is stored in a variable called outcome. For this, I will make use of a library in Python called random, and what it does is that it asks me to define every possible outcome. So in this case, there are 2 possible outcomes, win or lose. And then it also asks me, do I want to assign equal probabilities or weighted probabilities to these 2 things? So I choose that I'm going to act fairly, and both these outcomes are fair. There's no cheating, there's no bias, there's nothing here, right? So if if I just run this much code and print the outcomes, let's see what happens. So there we are. Lose, win, win, lose, win, lose, lose, lose. So randomly we are getting a random output from this particular line of code. And now let's segregate win from losses. So let's say if the outcome is a win, so if we get a win, and I'm going to choose the first element of this list. If the outcome is win, then what happens? If this happens, then we know that if there was a previous losing streak where losses were continuing, that losing streak will break. And secondly, we must keep track of that losing streak, because now once the win happens, that losing counter will get reset. And if we don't save this information, then we are going to lose the losing streak. So to do that, firstly, we need to increment the win counter because win has happened. So win counter gets incremented, and now if there were losing streaks in the past, we must save that number before it is overwritten or reset to 0. So if you remember, we were keeping track of all our losing streaks in this list. So we are going to append this counter, lose counter, in this. So we will save the previous lose counter in this before we overwrite it. So we have saved it, and now we are going to reset the lose counter. Now comes the second possibility. If the outcome was not win, then obviously it is a loss. So in that case, we are going to increment the lose counter, and here also, in case if the winning streaks were happening earlier, With this loss, that winning streak will be broken. So before we override the winning counter, we must save it. So I'm going to do exactly the same thing what I did here. I'm going to, instead of lose, I'm going to save the win counter in win streak list before I reset it to 0. So let's see if this much code is working or not. I run this code. So there's an indentation error here in the if statement. Yes. And also else, okay. So now the code will run. So there you can see what I'm printing here is win counter, lose counter, win streak list, and lose streak list. So if you see here, our win counter is 1. So the winning streak has started. So nothing is entered in this win list until this winning streak is over. But since the win has happened, then obviously the lose counter will not increment and it will be 0. And losing streak cannot start. So losing counter, losing list has got a 0 entry. And in the next run, the situation flips. The win changes to loss and the loss changes to win. So the winning streak is over. So we write this previous value in the winning counter, in the winning list. And now since this, losing streak has just started, so we will not append this list until this losing streak is over. So this is how this whole logic works. And we have one small set of problems here, which is, if you see the way the code is structured, if we are simulating, let's say, 10 games, and in the last 3 games, for example, last 3 tosses, 8, 9, and 10, we have a loss. So this lose counter will get incremented, but this lose incremental counter can only get written in the list if a win happens, and that win cannot happen because we have reached the end of the game. So to circumvent this problem, what we are going to do is, we are going to, if there's a non-zero value in any of these counters when the game ends, we just want to save that. So if win counter is not equal to 0, then we are going to, whatever is the last value in this counter, we are going to save it in the winning streak list. And a similar thing in case if the lose counter has got a non-zero value when the game has ended, then we are going to save that value also in the lose streak list. Right, so with this correction, let's just reprint and see if this is working. Yes, so correct. So you see the game has ended with the win counter having value 2, and this 2 value has been successfully appended in the win list. If we had not written the other piece of code, this 2 would not have got written in this particular list. So the last known values of the counters are getting saved. Now, if you see carefully, we have values like 1s and 0s in these lists. We also have values like 3 and 2. A winning or losing streak need to have minimum 2 wins or more, and or a losing streak needs to have 2 losses or more, 2 consecutive losses or more. So essentially 0 and 1 values are conveying nothing in these lists. 1 is conveying that there's a transition from win to lose, and 0 means that the other list is getting appended. So those 0s and 1s are required to be removed from these lists because we are keeping track of only streaks. So to do that, I'll make a new list, new win streak list, and slightly convoluted piece of code here. Basically, it's a list comprehension, which is nothing but a for loop. For x in win streak list, if x not in 0, what this means is that go through this win streak list, and if there are 0s and 1s, remove them. So the way we are making a new win streak list, we are going to do exactly the same thing for the lose streak list. So all these, by doing this, all these ones and zeros will disappear, and all the values which are 2 or above, like here, here, all these will get saved, because these are the true numbers which are signifying the win or lose streaks. Okay, let's just run the code so far to see if there are no errors. So code has run, there's no error. Now we are going to sort out these lists. For example, 2 is coming first and then zeros are coming later. We will arrange them in ascending order. Obviously the zeros have been removed, which I will show it to you once I print these statements. So to sort it out, I'm just going to take these lists again and use a command or a function called sorted, and I'm going to sort them in ascending order. So let's just print these lists to see whether the code is functioning or not. So there we are. Now, if you see the final list, our win counter, lose counter, win streak list, and lose streak list. In the final run of the game, we have 2 winning streaks, which are 3 consecutive wins, which is signified by number 3 and 3. And since we have removed zeros, so this list remains with only 3. And here we have a winning streak of 2, and after that all zeros and ones. So these zeros and ones have been removed, and in the losing streak only 2 losses have been indicated. So far so good, the code is functioning fine. Now we need to count the number of times such winning streaks have happened. For example, in this case, 3 times win has happened twice. So if we want to see whether the winning streak of 3 happens how many number of times, then we need to take count of these 2 numbers. So that count or that frequency can be is required to be counted. So let's call it frequency of win streaks, and for that I just use a function called counter, and I'm going to use a new list. And similarly for counting the frequencies of losing streaks, I will again modify the same code. So let's see what these variables or these lists they look like. So there we are. So here the winning streak list has got 3 and 4. So the counter has correctly counted that a winning streak of 3 has happened once and winning streak of 4 has happened once. And in this case, the winning streak, in the case of losing streaks, a losing streak of 3 has happened only once. So this value signifies that the frequency is 1. We can actually randomly run it again and check. So now you see that in this case, in the winning list, there is no number which is equal to 2 or greater than that. So that's the reason this list is empty. And in the losing streak, we have 3 times a streak of 2 that has happened. So the counter is counting it to 3. We can run it one more time and see similar results here. So there we are. 4 has happened, 2 has happened. So both of them have happened for the first time. So frequency of 2 is 1, frequency of 4 streaks, winning streaks is 1. And in the losing list, in the losing streak, we have a losing streak of 3 that has happened once, and rest all are below 2. So we are counting the things correctly. Now what remains is to see and to calculate the probability of these streaks happening, winning and losing. So I'm just going to use some print statement. The whole point here is that these counts, the counts that are happening here on per streak basis, I'm going to divide them by total number of runs of the simulation to calculate probability. So for example, in the winning list and the winning streak list, win streak of 2 has happened once. So this 1 divided by the total number of simulations that were done, that is number of simulations as listed here, is the probability of this streak to happen. So that way I'll be able to calculate the probability. So that's exactly what I've done. I've gone in, picked these counts from these frequency lists, and I've divided them with the number of simulations or the count of simulations, which is going to give me probability, and then there are some print statements. Similarly, for the losing streak, I've picked up the counts from the frequency of losing streak list, and then take each and every count and divided it by the total number of simulations that were done. So hopefully it should give us the probabilities. So there we are. So we have In the winning streak, as you can see that in the winning streak list, 2 has happened once and 3 has happened once. So 2 and 3 are appearing here, and similarly in the losing streak list, 2 consecutive losses have happened twice. So that's the reason why 2 is happening here, and accordingly the probabilities have been calculated here. So since the code now is functioning, we can increase the number of simulations. So let's simulate it 10,000 times. And remember that this is a fair game. It's a fair coin. There's no bias in the coin. And we want to know that in spite of using a very fair, unbiased random process, is it possible to generate random streaks in the outcomes? So there we are. I'll switch off all these print statements. Okay, so all the intermittent print statements have been removed so that we can see the results properly. So there we are. So now we are running this experiment 10,000 times, and we see that in the winning streak list, we are getting some very wild streaks. So here, this 13 signifies that 13 wins have happened in a row. It is possible. This number 11 represents that 11 wins have happened consecutively. If we see the losing streaks, the story is the same. We see that 13 times in a row we have lost. And there's nothing wrong, there's no cheating, there's no bias, there's absolutely fair game that is going on. But still, we are getting some very wild streaks. And this number is only going to increase if I increase the number of trials. So from 10,000, if I increase it to 1 lakh, you see some very wild streaks with winning as well as losing. 16 wins in a row, 15 wins in a row. Why these numbers? Okay, let me just increase the resolution of the probability. So you can see that there is a small probability that you can get 14 wins in a row in spite of the fact that the coin is fair. There is no cheating, there is no bias. Similarly, here also in the losing streak, you can have enormous number of consecutive losses without anybody manipulating the game, without anybody tampering with the coin. Now, why this is important? This is a very important probability paradox. It is called Hot Hand Fallacy, and it has come from gambling and trading and games which are games of chance. So when a gambler starts to win consecutively, he feels that he has got the hot hand and he has mastered some previously unknown trick or previously unknown skill, which is why it is giving him an edge. The reality is that he has not got any edge. It is just a streak which is happening randomly, and it is to be expected in such game of chances. The converse logic to this is that a lot many times people start losing and they lose multiple times in a row and they feel that they are doomed. It is because their lack of skills, it is because of their lack of knowledge, it is because they are not well trained that they are losing such kind of games. But the fact is, whether you know something about it or you don't know anything about this game, these losing streaks will also happen, and it has got nothing to do with your ability, your skill, your capability, nothing. So at times people becomes too adventurous and risky when they get into a lot of winning streaks and they think that they have mastered the game, but this is not the truth.